we will solve problems to determine the centroid of various sections. This is the first problem. Determine the centroid of the given T-beam about the x and y axis. The figure is given. This is a beam which is in the shape of a T, of the alphabet T. So it is called as a T-beam. All the dimensions are given here, 120, 20, 130, 20. All dimensions are in mm. The reference axes x and y are also given over here. So in this problem, we have to find the centroid of the given T-beam about the x and y axis. You have to find it about x and y axis. So how to proceed? Now, first of all, we can divide the figure into two areas. Now you see, this is the figure. We can divide the figure into two areas. Now, first area would be this rectangle 1, and second area would be this rectangle 2. This is this rectangle 1 and this is the rectangle 2. So the combination of rectangle 1 plus rectangle 2 will give the total centroid of the whole T-beam about x and y axis. See, we have divided the figure into two areas. Rectangle of base equal to 120 mm, height equal to 20 mm. This is the rectangle which has base 120 mm and height is 20 mm. Also, second figure is rectangle of base equal to 20 mm and height equal to 130 mm. This is the rectangle of base 20 mm and height is 130 mm. So we have divided this T-beam into two rectangles, rectangle 1 and rectangle 2. Now, next step is we have to consider each rectangle. First, we will consider rectangle number 1. Now, in this case, we will only consider rectangle 1. This is rectangle 1. We won't be considering rectangle number 2. Now, here B1 is equal to 120 mm and D1 is equal to 20 mm. This is the base of this rectangle, that is 120 mm, and this is the depth, that is 20 mm. Now this rectangle is at a distance of 130 mm from the x-axis, as you can see. This is at a distance of 130 mm from the x-axis and it is on the y-axis. This is on the y-axis. See, you can see over here, this we are considering rectangle number 1. It is at a distance of 130 mm from the x-axis, but it is on the y-axis itself. So the B1 is equal to 120 mm and D1 is equal to 20 mm. B1 is the base and D1 is the depth. I have written here 1 in the suffix because this is rectangle number 1. Now, A1 is the area of this rectangle. A1 will be equal to B1 into D1, as it is a rectangle. Its area will be B1 into D1. So it is 120 into 20. That comes out to 2400 mm square. Now, I have told you about the centroids of various shapes. For a rectangle, the centroid has to be at a distance of half. So this is x1. x1 has to be at half of the base. So x1 will be b1 by 2. You can see this is x1 and this is the base b1. So x1 will be at half of b1. So this is b1 by 2. That is 120 by 2 equal to 60 mm. y1, as we all know, we have to take through the reference axis x and y. So y1 will be with respect to this x-axis. I have told you before that x will be with respect to y-axis and y will be with respect to x-axis. So in this case, y1 will be with respect to x-axis. So from here till here, the distance is 130 mm. And from here till here, that will be equal to y1. Here till here, it will be d1 by 2. So we got y1 is equal to 130 plus d1 by 2, and d1 is 20. So 130 plus 20 by 2, we get it as 140 mm. So we have calculated x1 and y1 of this particular rectangle number 1. Now we will move to rectangle number 2. We'll consider rectangle number 2. You can see I have made only rectangle 2 here. I have ignored rectangle 1. This is the particular x and y axis. I have made the axis of symmetry over here. Now, this will be the distance x2 with respect to the y-axis. It has to be with respect to the y-axis. And this will be the distance y2. It is with respect to the x-axis. Now we have here B2 is equal to 20 mm. B2 is this base, that is 20 mm. And D2 is this depth, that is 130 mm. You can see D2 is 130 mm. So A2 will be equal to B2 into D2, that is area of the rectangle. So it will be 20 into 130, that will be equal to 2600 mm square. Now this distance x2, we got this distance as 50. How did we get this as 50? You can see over here, this total distance is 120. This distance is 20. So in order to assume it as a symmetrical figure, if this is 120 and this is 20, then this will be 120 minus 20. This distance will be equal to how much? 120 minus 20 divided by 2. That will come out to 50 mm. And this will be the same 50 mm. So you can cross verify. This is 50. This is 20 plus 50. 50 plus 20, 70, 70 plus 50, 120. So this total distance is equal to 120. So this much distance is equal to 50 mm. So this much distance is equal to 50 mm. And this is the base, that is equal to 20 mm. I have considered here base as B2 and depth as D2. So what will be x2? X2 will be with respect to the y-axis. So this distance is 50, and from here till here it will be half of the base. So it will be 50 plus B2 by 2. So 50 plus 20 by 2 is equal to 60 mm. And y2 will be what? Y2 will be with respect to the x-axis. So it is touching the x-axis itself. The rectangle is touching the x-axis. So y2 will be equal to d2 by 2. And d2 is 130 mm. So that will be 130 by 2, which is equal to 65 mm. Next step is to find out the CG about x-axis. So now you can see x bar, I have told you in previous video, x bar is equal to a1 x1 plus a2 x2 divided by a1 plus a2. In this case, we have only two areas. This is area 1 and this is area 2. So we get the formula as a1 x1 plus a2 x2 divided by a1 plus a2. We know a1, it is 2400. a1 is equal to 2400. x1 is equal to 60. So this will become 2400 into 60. plus A2 is 2600 and X2 is 60. So this will become 2600 into 60 divided by 2400 plus 2600. So when we type this in the calculator, we will get x bar equal to 60 mm. X bar is the distance with respect to y-axis. And CG about y-axis will be y bar is equal to A1 y1 plus A2 y2 whole divided by A1 plus A2. Now A1 we got, y1 we got 140, A2 we got 2600 and y2 we got 65. So putting all this in the calculator, we get the value y bar equal to 101 mm. Hence, the centroid of the given figure is x bar y bar is equal to 60 101 mm. Now, coming to the next problem. In this case, this is an eye section. Determine the centroid of the eye section shown in figure with respect to the axis shown. See, this is the eye section that is given. This is the reference axis x and y. All the dimensions are mentioned over here. This is 80, this is 12, this thickness is 12, this total height is 150, this depth is 120. All dimensions are in mm. It's mentioned over here that all dimensions are in mm. And here there is a special case. Y0, Y0 axis is given. You can see this is Y0 and this is Y0. Y0 is axis of symmetry. It means that the Y axis of symmetry is already given. Means that this eye section must be passing through this axis of symmetry. Somewhere it must be on this axis of symmetry. So we have the value of x bar. We know the value of x bar. This would be the value of x bar. We have to find the value of y bar. Y bar must be lying on this axis of symmetry. How much would be the value of x bar? It would be 120. This is 120 minus 80. Or x bar we can calculate as 120 divided by 2. It will be somewhere over here. That would be 60 mm. X bar should come out to be 60 mm. Now how to solve this problem? Here we can divide the figure into three areas. Rectangle 1, rectangle 2 and rectangle 3. See, this is rectangle number 1. This is rectangle number 2. And this is rectangle number 3. So we have divided the area into three rectangles, 1, 2 and 3. Now we have to consider each rectangle to find out the center of gravity or the centroid of the given eye section. Now if we consider rectangle 1, this is rectangle 1. We have only considered that rectangle. We have ignored rectangle 2 and 3. So in this case, the B1 is equal to 80 mm. D1 is equal to 12 mm. You can see this is B1 that is equal to 80 mm and this is D1 that is equal to 12 mm. So A1 will be what? B1 into D1, that is 80 into 12, that is equal to 960 mm square. X1 will be equal to 20 plus 80 by 2. Now X1 is what? This is X1. X1 is the distance. X1 is the distance with respect to y-axis. Now this is X1. From here till here, the distance is 20 mm. As you can see, this distance is 20 mm. Now how did this distance come to 20 mm? I am talking about this distance. This distance would be equal to what? 120 minus 80 divided by 2. 120 minus 80 would be 40, and 40 divided by 2 will be equal to 20. So this comes out to 20 mm. And you can see from x-axis till this triangle, this rectangle, the height is 138 mm, because the total height of the I section is 150 mm. So from here till here, the height would be equal to what? 150 minus 12, that comes out to 138 mm. So I have written here the height as 138 mm. So we will get the value of x1. x1 will be what? 20 plus this 80 by 2. From here it will be 80 by 2. So we got it as 20 plus 80 by 2. That comes out to 60 mm. And y1 is this distance with respect to x-axis. y1 will be what? It will be equal to 138 plus 12 by 2. 138 plus 12 by 2. That will come out to 144 mm. Now, next is you have to consider rectangle number 2. Now, in considering rectangle number 2, the base is what? Base is 12 mm. Base B2 is 12 mm, and the depth D2 is 128 mm. That you can calculate because this total height is 150. So 150 minus 12 minus 10 will give you this height. That is equal to 128 mm. So this height comes out to 128 mm. And from here till here, the height is 10 mm. So what will be x2? x2 will be the distance with respect to y-axis till the axis of symmetry. This is the axis of symmetry. So x2 will be equal to 54 plus 12 by 2. This distance is 12. So half of 12. 54 plus 12 by 2. Now from where did this 54 come? 54 is this distance. You can see 54 is from this distance till this distance. So this distance will be equal to 120 minus 12. 120 minus 12 is how much? That will come out to 138. Sorry, 108. And 108 divided by 2 will be equal to 54. So this distance will be equal to 54 mm. So that's written over here. This distance is 54 mm. So x2 will be equal to 54 plus 12 by, this is 54 plus this distance will be 12 by 2. That is x2. So it comes out to 60 mm. y2 will be equal to, this distance is y2. It will be equal to 10 plus 128 by 2. This is 10 plus 128 by 2. So it comes out to 74 mm. Next, you have to consider rectangle number 3. Now, in case of rectangle 3, it is lying on the x and y axis both, you can see. So this distance, we get the base as 120 mm and the depth as 10 mm. This is the axis of symmetry. This is the axis of symmetry. So x3, first we have to calculate a3. a3 will be b3 into d3. So that will come out to 120 into 10 equal to 1200 mm square. x3, this distance will be half of the base. x3 has to be with respect to y-axis. So x3 will be equal to 120 by 2. That comes out to 60 mm. And y3 is this distance. y3 will be equal to this 10 divided by 2. So 10 divided by 2 is equal to 5 mm. So putting all these values in this formula, this is CG of x bar. So x bar is equal to a1 x1 plus a2 x2 plus a3 x3 whole divided by a1 plus a2 plus a3, because in this case we got three areas. In the previous problem we had only two areas. So we'll substitute all the values and we got x bar as 60 mm. Similarly, y bar is equal to a1 y1 plus a2 y2 plus a3 y3 whole divided by a1 plus a2 plus a3. Just substitute y1 in place of x1, y2 in place of x2 and y3 in place of x3. You will get the value of y bar. Putting all the values in this, you will get y bar equal to 69.78 mm. Hence, CG of the required I section is x bar y bar is equal to 60, 69.78 mm.